Hello, this is Tamisha with Educational Tutoring Centers. We offer online tutoring to students all over who have access to the internet, and we also offer in-person tutoring in a number of states. To find out what services are available to you, please contact us at the telephone number listed at the top right of our screen. Now today I am going to do a video for a trigonometry course, and this is at the college level. You might also see a problem like this in an advanced course in high school, advanced math course. This problem says use the values below to find the values of all 6 trig functions. And the information that's given is that the secant x is equal to a negative 3/2 and the tangent x is greater than 0. Okay, I've listed on the left side of the screen some fundamental trigonometric identities, and they are the reciprocal identities and the Pythagorean identities, and we won't use them all, but those are some options that are available to us in order to find those values. So here given to us is the secant, and we're told that the tangent is greater than 0. So the first thing I'm going to do is set up a coordinate plane, and just as a review, I will label each section, each of the quadrants. This is 3. And 4. And then the other easy, quick way that you all can learn the sign of the basic trig functions is to remember the saying that all students take calc. And what that will help you to remember is that in the first quadrant, all of your basic trig functions are positive in the first quadrant, and in the second quadrant, sine is positive. In the third quadrant, the tangent is positive. And then in the fourth quadrant, the cosine is positive. And so that's all students take calc. Okay. All right, so here the quadrant for tangents being positive will be in the third quadrant. So this is the quadrant that we're considering, and here the x values are negative and the y values are also negative, and of course the hypotenuse, which would be the radius on a unit circle, which would, distance is always positive for your radius anyway. Okay, so let's see. What do we have as options? This is an option here because it has the secant listed. I don't know what's happening to my pen. And here we can use this one because it has secant, and we could also use this one here because it has secant. Okay, so let's see here. I think I'm going to go ahead and use this one here. So I'll substitute negative 3/2 in place of secant x, and set that equal to 1 over cosine x. And then I can cross multiply since this is set up as a proportion. And I get negative 3 cosine x is equal to 2. And to solve for cosine, I would divide both sides by negative 3. So then cosine x is equal to a negative 2/3. Okay? So remember, we're solving for sine x, cosine x, sine, cosine, and tangent x. And then, of course, their inverses would be the cosecant, the secant, and the cotangent. So we have the secant, which is the inverse of the sine. So this, I'm sorry, the secant, which is the inverse of the cosine. C equals negative 3/2. And this is the reason why cosine is negative 2/3, because it's the reciprocal. Okay, so we have the cosecant that will be there. And down here we'll have the cotangent. Okay, so we have the cosine and we have the secant. So I can now take that secant value and I could plug it in here in this Pythagorean identity and solve for tangent, or I could take the cosine here and solve for the sine. And I think what I'll do is actually just both, so that I can, let's see, I need the okay, so I'll plug it in here and get the tangent. Okay, anyway, I'll plug it in here and go ahead and get my tangent value, and then I'll have my cotangent, and then I'll start working on my other functions. So it's 1 plus tangent squared x is equal to secant squared x, which is negative 3/2, and we will have to square it because of the square on those. We have to have squares here and here. So then that's 1 plus tan squared x is equal to 9/4. And then I'm going to subtract 1 on each side in order to isolate tangent here on the right side. Tangent squared x is equal to, now this value of 1, I'm going to go ahead and change it to its equivalent, which is 4/4, so that I'll have the same denominator as this fraction that I'm subtracting it from. And so that will leave me with 5/4. Now tangent isn't equal to 5/4. Tangent squared is equal to 5/4, so I'll need to take the square root. And then so tangent squared x is equal to plus or minus square root of 5/2. Now it says plus or minus because whenever we take the square root, it produces two answers. It's the positive and negative. So we need to look to see which one we actually need. And here in the third quadrant where we're actually working, it says that tangent is positive. So we'll take the positive of that value. So tangent is square root of 5/2. And of course, cotangent will be the reciprocal of that, which will be 2 square root of 5. And once we rationalize the denominator, then we'll end up with 2 square roots 5/5. Okay, so 2 square root 5/5. Alright, and now we need to work on sine. So I could take my value here for cosine and substitute it into this first Pythagorean identity and solve for my sine. So I'll say sine squared x plus cosine, which is negative 2/3. So negative 2/3 squared is equal to 1. And so sine squared x is equal to plus 4/9 is equal to 1. And then I'm going to subtract 4/9 on both sides. And so sine squared x is equal to 1, which is equivalent on here, is 9 over 9 from 4/5, which leaves 5/9. And then when I take the square root of both sides to get sine x, I get square root of 5 over 3 for my sine value. So square root of 5 over 3. And the cosecant is the inverse of that, which is 3 square roots 5. And rationalizing the denominator, rationalizing the denominator, I would get 2 square root of 5 over 5 for my cosecant. So 2 square roots 5 over 5, and that is the plus or minus of it. So here in the third quadrant, sine is negative, so I take the negative of that. And of course here sine is negative, so the cosecant is also negative. So we have the value of our 6 trig functions now. Okay, thank you for watching. Please be sure to click on like if you like this video.